Hey guys, so let's take a look at some of these area between the curves questions here that we have. So I'm going to go through and solve a couple for you, but really, I'm not going to do every single one on the video, but I'll post the solutions for you, okay? So let's just take a look at this. So if we're taking a look at this problem, so for each of the problems, sketch the curves and shade the regions, find the area of the region enclosed by the curves. You may use your calculator to evaluate the integral, but no need to show proper integrals, but you need to show proper integral setup. So I'm just going to do the setup on these videos, right? And then we'll have the answers right at the end there, okay? So let's take a look. So okay, we have I'm going to graph these two ones first. X equals 3 and x equals 5. Okay, great. All right, 3 and 5, those are x equals, not y equals, x equals. All right, so I got those two. All right, this is going to be a parabola opening down, right? And you could worry about, there's lots of different ways to graph this. Remember, all we really care about is what's going on between 3 and 5. So you don't have to worry so much like this one here is going to be crazy with where the vertex is. But for this one, I can pretty easily factor it. So I'm going to do that. Let me just double check my factoring. I know I made a couple mistakes in the last one. A couple people emailed me about it. I'm just going to be careful here. Okay, that looks good. So I got 0 and I got 4 as my zeros there. Okay, so 0 and 4. It's opening down. So that means that the parabola is going to be something like this at 2. If I want to know where exactly it is, you can always just plug in the endpoints, the 3, and plug in the 5, and that would tell you. Okay, so that's the way that always works, right, for yourself to know exactly where it's going to be if you're not certain. Because I've done a couple graphs in my life, I know that the vertex is going to be here, right, and that this graph is going to be something like this, where that's this equation. I'm going to use pink for the other one. Right? For this one, I'm not, I could figure out what the vertex is. Not really important. I'm just going to think about where 3 is. Right? So if I plug in 3 there, 2, 3 squared is going to give me 9 minus 48 plus 34. So this is this function. I'll call this one f of x. So this is f of 3 right here. I'm just trying to figure out where it's going to be. So it's 18 minus 48, so negative 30. Right? So it's going to be a 4 for myself. So it's going to be right here. I do know it's opening up here. I just don't know where the vertex is. So I'll just plug in 5 and see what happens. That's going to give me 50 here. Right? That's going to be minus 80 and plus 34. I did some of that math in my head there, right, just to make it easier for myself. So that gives me negative 30 plus 34. So it's 4 again. Right, so it's going to be here, and remember it's opening up because it's a parabola opening up. So this is the top function. So it's going to be something like this. So there's my region, right, between the curves. And if I think about those slivers we talked about, right, the sliver right there, I'll use pencil for this, right. There's my rectangle, right, that I'm going to have right there. You can see its thickness is dx, so that tells me my integral is going to be in terms of dx there. Okay, my bounds are going to be 3 to 5. And so I'm going to take the pink function and subtract the black function for myself, the pink function being the first one. So if I call, so I might not have enough, pencil, I can erase it. 2x squared minus 16x plus 34, taking away negative x squared plus 4x dx. Okay, thank you, Joe. That's my daughter. They're working on Legos downstairs. So, okay, so there's my setup. Okay. For myself. Okay, let's take a look at the next graph here. Right, so I'll use black for the first one and pink for the second one here. Okay, let's see. I need to go between negative 3 pi over 4 and negative pi over 2. So that's going to be, I really only need to worry about between here and here. Okay, so if you don't remember what the graphs look like, it's not the end of the world. Maybe hopefully you remember cosecant, right? That's going to have its max at 0, 2, right? 2 because there's amplitude of 2, and then it's going to come down to 0, right? And then it's going to bottom out here at negative 1. I'm sorry, negative 2 when you're at negative pi. So there's that function. Okay. Cosecant squared. We don't all remember cosecant squared. No big deal. I'm going to take that. I'm going to plug in, right, my endpoints, negative pi over 2 there. For 2 cosecant squareds of negative pi over 2. Okay. The sign of negative pi over 2, that's negative 1, right? Flip it, it's still negative 1 squared. It's positive 1, so that's 2 overall. It's right there. Okay, so it looks like it's going to be a larger function for me. Oops, I put it in the wrong spot. That's going to be there. Okay, then I'll plug in negative 3 pi over 4, 2 cosecant squareds of negative 3 pi over 4 for me. Okay, and so if we think about it, cosecant, so the sine of, well, I'm going to just think about pi over 4. Sine of pi over 4 is root 2 over 2, or 1 over root 2. Okay. Now it doesn't matter what quadrant we're in, because you know that this is a different quadrant, but it's going to, remember, sine's always the same. It's either positive or negative, but it's going to be squared. So if I flip this, the cosecant of pi over 4 is root 2. If I then square it, it's going to be 2, so that equals 4 overall. Okay, so I can see my graph is going to be, right, oops, going to go up here. So there's where my graph's going to be, something like this. Right, not really caring too much about how the curve is. I just need to know which one's the top function, which one's the bottom. Right. If I make a rectangle to find the area of this, here's my rectangle. My rectangle is going to look like this, with the top being the black function, the pink being the bottom one. Okay, and I'm integrating from negative 3 pi over 4 to negative pi over 2. My top function again, the black one, that's the 2 cosecant squareds of x, and then I'm subtract the 2 cosine of x, right? And that's dx. And no, there's my setup for it. Right? And if you look at this, at first looks kind of like, oh geez, we have to deal with these functions, but hey guys, we can integrate that. We can integrate this both pretty easily. Okay. Next one here. Right? I'm going to do the same thing. Right? What I like to do is I like to put my boundaries here, 0 and 4. Okay. Right? Looking at the black function there. Right? So that's 0. Here, and then at 4, that's going to be square root of 4 is 2, so it's going to go up to 6. So my function is going to look something like that. Okay, remember, the curvature doesn't really matter, so if you don't remember exactly what it looks like, so what? Not the end of the world. You'll still be able to get this, because we really just need to know which one's the top and which one's the bottom. That's the focus, top and the bottom, right? So our sliver is going to be right here. So that means we're going to be integrating from 0 to 4. The black function's on top. Pink functions on the bottom. Right? That's my integral I'm going to work with there. Okay. All right. So for this one, I just really just plugged in points and got the two ends. So that's a great strategy to use for yourself, especially if you have a calculator. If you don't want to do all this work with trying to find those trig functions, right? You don't have to. You can figure out. You can just plug it in to get those values there. Okay. Number 4 is basically going to be the same as that, and you can just see it's more of the same on the next page there. So if you have any questions on what I'm gonna put my solutions online, but if you need me to talk through any of them, just send me that email and I'll check it, because I'm still on until next week, right, for myself. Okay, then we have some open response questions here for ourselves, and so you will these ones, they take some time, so, and it's just keep in mind that Mr. Warner wanted to just skip a couple of these problems, right, for ourselves. It's basically all going to be the same as what we have there. But let me just, I don't know, I'll try this number 11 here, right, for ourselves. So let the region R be in the first quadrant enclosed by these graphs, the 8x cubed and the sine of pi x, as shown in the figure above. Doesn't tell us which one's which, but we can figure out that this is the sine just because we know what sine looks like, and that's the and this is the 8x cubed. All right, notice this is a non-calculator, so you would have to figure that out on your own. Hopefully you can. Write an equation for the line tangent to the graph of f at x equals 1/2. Okay, we can see that this has nothing to do with area, right? Nothing to do with area. So for part A, right, you're just going back to tangent lines. So f right there. So f prime of x equals 24x squared. Okay, make sure the next step you plug in the 1/2. You can't do it in the same step there. You can't just like all of a sudden like get the number there. If the AP wants to see that you're plugging in that 1/2 afterwards, make sure you put that prime symbol there to show which function you're plugging into. Okay, so we get 6 there, right? We also are going to need, we already have that location there. So for this one now we have y minus 1 equals 6x minus 1/2, right? And A is all done there. Okay, so in the AP, it looks like there might be another part to this if this was truly an open response. But if I was thinking about how this is graded, you probably get 1 point for this, 1 point for this, and 1 point for this. So this is probably 3 points for part A. For part B, find the area of the region, right? Really, for this one, we just have to look at which one's the larger. We know we're going from 0 to 1, so you get 1 point for, 0 to 1/2, so you get 1 point for setting up those bounds correctly. And we can see that g of x is larger, so we can do g of x minus f of x, right? Okay, you can write the functions in if you want, but AP doesn't even care about that. All right, they want to see this. So you're going to get 1 point for this, 1 or 2 points for this, and then probably 1 point for doing the antiderivative and 1 point for actually evaluating. Right? So that's more of the same of you've done before. So I'm not gonna talk you through that. You can see my solutions online. Okay. Just looking at this, we're skipping B for now. After next week, Mr. Warner will do that with you. All right. And then. But the other parts, these two look basically the same as what we have there, as does number 13 there. Right? Okay. So you'll see the solutions posted online. Hope that video helps you to understand how to tackle those problems.